On each tangent field below, sketch the solution through the given point. The first one is dy dx equals x, and we're going through the point A, which is 1, -2. It might be difficult for you to see the grid too well on this video, but 1, -2 is here. You can just about see the 1 on the axis here and the -2 on the axis there. And so we're going to go through that point. Before we do that, I'd actually like you to look at the structure of the field itself, because you're going to have to be able to draw fields and recognize fields as well. So dy dx equals x. That means when x is 0, we would expect a horizontal tangent. And you can see all the way down the axis here, the graph is completely flat. We'd expect when x is 1, all the way along there, the gradient to be 1. And over here, where x is -1, all the way down there, we'd expect a gradient of -1, and so on. And it's worth just pausing this video as you go through, because I'm not going to go through this for every single field. I might have a look at 1 or 2 of them, but have a look at the structure of the field and see if it's what you would expect from the differential equation. Now, if you have the calculator available when you're doing this sort of thing, it's easy to draw the differential equation. I've got dy dx. I've still got x over y here. Thought I'd change that. Sorry, I'll just do that. Let's just do that and draw the graph. And you can see what the graph looks like. It looks like a quadratic, and you'd expect that because if you integrate x, you get x squared over 2 plus a constant. So you're going to expect a member of the family y equals x squared over 2. So you're going to expect to see a quadratic. And you can draw it by following the field. Something else you can do if you've got the calculator available is just do a sort of trace thing here. And you can see that it's going to cross the axis there at... I've still got the old initial conditions in. Let me quickly change those to our new conditions of 1 and -2. I don't know if the trace will stay on the graph when we redraw it, but it's okay. If it doesn't, we just redraw it. The trace has stayed, so there you go. And oh no, it hasn't. That's just our point. Okay, let's put the trace back on, and then we can get a good idea of what the axis intercept is by going in close there. You can see it's going to be at about -2.5-ish. And so on our graph, that's probably what, about here. And then you could use the trace to do this really accurately, or just try to, as you go along, just follow the tangents as they come along. And this one, you know it would need to be symmetrical, so let's try to do that and try and get it reasonably symmetrical. Again, if you've got the calculator available, use the trace, find a few points, and you can get it really accurate. More often than not, though, you're just going to be on your own trying to do this. dy dx is equal to -x squared, and we're going for 1, -2, which is the same point that we had before, point A on the other graph. So 1, -2 is this one just here. Now think about this, what we're going to expect. We're expecting a cubic, so we know roughly the shape, but try to follow the tangent field. We know it will be horizontal here, and then it's going to get steeper as it goes out. Try to follow the actual gradients. You can see they're really steep there, like that, and again getting really steep here, like so. That may or may not be that fantastic. Just do the best you can, though. If you don't have the calculator available, do try to follow the actual little marks on the tangent field. Try and follow along those if you can. We've got dy dx now is equal to x over y, and we want to go for 0, 1. So 0, 1 would be about here on our graph. And if we follow that one, we can see that that is going to tend to this asymptote. It's going to have like an asymptote of y equals x and an asymptote of y equals negative x by the looks of it. So it's going to do something like that. Now we will have a bit more of a look at this next one. dy dx is equal to y, 2 minus y. And we want to look at each of those 3 points. First of all, when y is equal to 0, that's on the x-axis, we should have horizontal gradients, so straight along the axis. Also, when y is equal to 2, that would be 0, dy dx would be 0, and it should be horizontal along there. And we can see this across here. So, let's have a look at these different solutions. Negative 1, 3. So negative 1, 3 would be around here. And if we do that, we can see that's going to come down very sharply there. But then it's going to asymptote out that way. What's going to happen for the solution at 0, 1, which is this solution? That is going to go up here, and then it's going to asymptote to that, and it's going to come down here, and I think it's going to asymptote out that way. And then we've got 1, negative 1, which is about here, and that looks like it's going to go sharply off the bottom of the graph there, and it's going to come over and it will asymptote out that way. You can explore a lot of this on the calculator, and you can find actually better things to do it with than the calculator, like Desmos and so on. Have a really good look and make sure you understand this. It's not usually worth a lot of marks. It doesn't always come up in the exam, but it's definitely going to come up in a test. And if you've practiced it, it's pretty easy. So make sure you get the marks.